Hot chocolate, Azure Cosmos Data.
Entity framework, our tools.
Net40 suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Likeness.
Shay Rojansky.
Grace Lanson.
Arthur Vickers.
.NET Data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Standup.
Awesome. So we are live. Welcome, everybody. And today we have a great topic with Davide from the SQL Server team about the vector search and everything vector related and AI related. Before we start, I will do the same stuff we do every time and tell you about the latest preview that you can try. So you might have noticed the preview 4 is out of the door. So if you go to different places like NuGet or normal .NET downloads, you can download .NET 10 preview 4 and EF Core 10 preview 4 and everything around it. And in this one, we have quite a few new features. So the first one that's available, and it would be nice if you would try it and provide feedback and everything, is the full text search support for the Azure Cosmos DB. So now if you are using EF Core and Cosmos DB, it brings the next step in our effort for supporting more features from Cosmos DB, and this time it's the full text search, which is also quite a new feature. So if you want to try that, you can do that. You can enable the full text search and you can create a full text index on different properties in your documents. You can use different full text operations, basically full text contains all, contains any, and full text score. Related to the topic that we are actually going to be talking about today is the hybrid search as well. So if you are using RRF, or if you want to use RRF, you can now do that with EF Core as well, combined with the hybrid search on the Cosmos. And the vector similarity search finally exits the preview. So in EF Core 10 preview 4, it's no longer experimental, and you can start playing with it. We have new APIs like isVector property, isVector index, and so on that you can use. Obviously, we have a bunch of small improvements, again, between preview 3 and preview 4. These might be really nice for you, or not, depending on where you are. So definitely check out the release notes and try the previews as well. Anything I forgot, Shay?
Not that I remember. I don't think so.
Awesome. So let me welcome our guest today. He is actually from the SQL Server division department team. So we are a close partner with them because obviously EF Core and SQL Server are working hand in hand. Davide Mauri, and he will be telling us all about the latest features that are available basically in Azure SQL, SQL Server, and all these different editions of SQL Server. And that's the vector search.
That's
so
right.
welcome.
Yeah, thanks a lot for having me. It's been a pleasure to be here. So should I get started?
Yeah, I mean, by the way, we know Davide for a long time, and we've been in a lot of meetings, and we've been working together to make sure that everything plays together well, and all of the features that Davide works on the Azure side and also SQL Server, we also have to enable on our side, both in EF. But there's also questions even around how it works with SQL Client, and there's tons of stuff that has to happen, like in order for everything to actually be nice and good for the developer. So it's really a special pleasure for me to have Davide finally here, like on our show.
Thank you. So, and actually, one of the most complex things that people may not understand how complex it is actually adding a new data type, because supports goes from the server to the protocol to the driver to EF Core, and exactly that is what we did to support vectors. So that's why we are being in so many meetings together and working on it, right? Just to give everyone who's listening and watching this a little bit more of context. So let me share my screen, because I want to kind of guide you to a little bit of a journey. We will start from scratch with vectors. I'm pretty sure now everyone is a little bit at least comfortable with the terminology. So I'll show how it works in SQL, but then I guess developers really want to understand what they can do and what can be exciting. And honestly, vector alone are not exciting, but exciting is what you can do with them. So I will be building, I will be showing a repository that everyone can use. I'll share the link later. That shows how you can build an agent to help a fictitious insurance company to provide a better service to their customers. And you will see the agent, using the vectors behind the scene, but also creating a query on the fly for you, the developer, and we'll be using semantic kernel behind the scene. So that's my plan for today. So let's see how it goes. It's all live. So let me first of all start to share my screen. So here, and share screen, and here we go. You should be able, yes, seems everything is working. So the first thing I want to share is that we added the vector type in the SQL engine. So it's available already in Azure SQL Database for free. There is no additional cost. It's not behind any private preview thing as it was months and months ago. So it's just there, free to use for everyone. It's available also in the managed instance and also in Fabric if you are using SQL in Fabric. And it's super easy to use. It's basically you have a new vector data type, you specify the number of dimension, and that's it. Then you treat vectors from a human perspective as JSON arrays, which is the most common way to move and represents vector today. And that's pretty much it. So once you have your vector, actually, let me show it in real time. I have a simple example here ready. So in this case, I'm creating a vector of 3 dimensions, but you can go up to near 2000 dimensions, which is more than enough for doing all the AI work needed today. And then you have this nice function called vector distance, which allows you to calculate the distance between one and the other vector, specifying a metric or a distance function. Here we are using the Euclidean distance. So the distance between these two vectors will be 2 for sure. Let's see if the math is right. Perfect. Or we can calculate other distance. The other very common is called the cosine distance, which is basically measure the angle between the vector. And this is 0 point something, usually something between 0 and 2. And the closer is to 0, the more similar or the closer the two vectors are, right? This is just so basically this is the big news. So not much in the sense that it seems pretty easy, and I don't know what I can do with it. But I think the interesting part is then when you realize that vector per se are not that much interesting. What is very interesting is when a vector represents something in the human world, like a sentence or a phrase or a topic or something, right? Something that is real. Because the moment you have a vector that is able to capture a semantic meaning, and here I have, let me find the right, this one, I think. Oh, it was already here. Yes. So the moment you can have a vector representing semantic meaning of something, let's say I want to represent a king, or I want to represent a queen, or pizza, or maybe let's say even do something else here. And what I'm doing is right now is generating the vector using an AI model. Now, this storage procedure is connecting to OpenAI and taking this text, let's say food, this time, and turning that concept into a sequence of number, a vector. Now, this is very interesting because it means that the vector has some real meaning. Now, we just said that we can calculate the distance between two vectors. Two vectors that are close will have a very short distance between each other. Well, the moment we take a topic and we turn it into a number, and then we can calculate the distance between two numbers, it means that we can calculate mathematically how much two topics are close or distant from each other. So this enables what is called semantic search, because you can take some text, in this case food, pizza, or whatever, turn it into a vector, take another text, turn it into a vector, calculate the distance. If the two vectors are close, you know that the originating values for those vectors are also close, which means they are similar, right? So this is basically why we wanted to have vector in database, because it enables to have a better search, for example, more refined way to find topics and answer common questions that you may have on the data in your database. So let me show you an example here, and add me food. Now, oops. As you can see, the vectors are pretty big when you come to vector generated by AI model. Those are called embeddings. So embeddings are vector that has some meaning related to something in the human world. And so let's create a food vector. So 1536.
What's that 1536, Davide? The thing in parentheses?
That's right. That's the number of dimensions that the vector has. So just like here, we had a vector with 3 dimensions. So 3 values, 3 points. Basically, imagine a vector as a point in space, in a multidimensional space. So these are the coordinates, right? Now, the AI model, to correctly represent some topic in a sequence of numbers, they need to have a lot of dimension. 1536 is probably one of the most common. It's the one that by default is used by OpenAI, for example, for generating embeddings. So what I'm doing here, and actually let me also show you this nice storage procedure. I can show you this one. The get embedding procedure I created is nothing more than a sort of a wrapper around the equivalent of curl. So SP invoke external REST endpoint is a storage procedure we added in the engine that allows you to call, just like you would do with curl or HTTP client, and an HTTP endpoint, right? So here I'm calling my deployment of the embedding model in Azure. And here, so I am calling the OpenAI embedding model called text embedding 3 small. There are many. I'm choosing one of the most common and asking to have these values turned into vector. Maybe let me show you a vector just to show you how it looks like. And that's it. That's my vector. So huge sequence of number. This is what the word food means in terms of AI mind, if you want, right? So when you say food, AI understand all these sequence of number. Okay, that's fine. We don't need to understand all those numbers, and we will never, because it's made by AI for AI. But this means that, for example, I can then calculate the distance between, for example, let's say food and pizza here, between different vectors. So the vector that represents a king against itself, so that should be the closest, right? Then king, and I want to understand how close it's to a queen topic, or to pizza or food. So let's see what happens. So let me comment is out, and run this one. Basically, you will see that a king, this is a super tiny number. It's 2 point something at the minus 16. So it's 0.16 zeros, right? So it's basically 0, which is what we expect because something is always similar to itself. So that's great. That is basically like our proof that everything is working. Then a king is definitely more conceptually similar to the topic queen than to a pizza. So again, this seems that is working. So we are able to clearly agree that king and queen are more similar to each other than king and pizza because pizza is a food. So yes, food versus pizza, definitely it's closer than pizza versus king. Which, because again, food is a generic type of, pizza is a generic type of food. So it makes sense that the distance between pizza and food is smaller than the distance between pizza versus a king. So this is kind of the foundational aspect that allows us to say, well, that is cool, because if I can take the text in my databases, imagine a description, a contract, or something, a blog post, and I want to search for, let's say, all the blog posts that are related to something more complex, right? Here I'm typing a word, but I can really type more than stuff. I like pasta, for example, a lot. So I can vectorize or turn into an embedding a huge portion of text, right? And the AI model assures me that as much as possible of the meaning behind the text will be captured in the vector. So what I can start to build is what we call semantic search. And semantic search is something that basically requires you to get the embeddings, write a vector distance query. And I know that many developers love T-SQL. I definitely love T-SQL, but many also loves to just do it via C# or tools like EF Core. So that's why we added support for EF Core, so that let's say you have your blogs and your posts, right? So it is a very common example. So you have a post with the title and the content. Now, and of course, now I want to start to use this embedding to improve the search. So what I need to do is generate the embedding and then do vector search. I can do everything in SQL, but I can also do everything in C# with the aid of EF Core. So that's exactly what I'm doing here. I took the sample that you have on your Getting Started guide for EF Core using blogs and post. So I have my blog class and the post, and my embedding, of course, is declared as an array of floats because that's exactly what an embedding or a vector is. And then what I just did is that, of course, I create my context, make sure that the blog exists. Otherwise, I create it. Then I read some of sample blog content from a JSON file I provide as an example, and add to the database. And now it's nice that I can just say, okay, I'm using EF Core, so I can just do blog.post.add. How do I generate my embedding? I generate the embedding on the client, so I'm pushing the entire vector from my client to the database. Again, it's very easy. And here I'm using the OpenAI library to generate the embeddings. Before I showed that I was doing it from SQL. Of course, you don't need to do it from SQL. You can do from any place where you can actually call the embedding model that you have. So here I'm using the OpenAI library. And then I'm getting the vector, storing the vector in my class, and then just saving the changes. So this is basically sending the entire vector to my database. And then here, it is very elegant. I just take a sentence I want to search for. Let's say I want to search I want to use Azure SQL, EF Core, and vectors in my app. That's the topic I'm interested in. So imagine talking to an AI model. So I need to embed this, turn this into an embedding. That's exactly what I'm doing. So I'm getting the vector that represents this content. And then I'm using an extension that you nicely created called EF function vector distance that allows me to tell EF Core that I want to use the new vector distance function to take advantage of the ability to query vector right in database. So we push basically the complexity into database, so it can search between all the vector that I has in the fastest way possible. And then we get the result. So this is very simple. And if I do run this, it will just work as you expect. And I think I enabled, let me check. I think I enabled some, oh, I didn't. So let me stop and actually enable. So you can see the query running. And let's run it again. So this is the first step, I would say, just to start to have embedding in your application. You can just use EF Core, basically. So it's the easiest approach possible, I would say. How I'm doing? So, it's all clear. It's all new, I guess.
I mean, we're not exactly your typical crowd here. Both Yiji and I know a thing or two about embeddings and vectors and things, but
I guess
awesome presentation. I'm assuming, like, of course, everybody, you know that you can ask questions in the chat, and both Yiji and I are monitoring them, and we can surface any questions also to Davide here. So please don't be shy. You can absolutely ask your questions. I will maybe note just one thing. So this thing that Davide showed, which is the EF Core support for the vector search, is something that we coded up. It's a plugin. It's not part of EF Core yet, mainly because the actual support for vector search in Azure or in SQL Server is still preview. So we kind of coded it up outside of EF Core as a plugin, which is also a cool part of EF Core, that you can just do things as a plugin and you don't have to. That the extensibility story is very, very important, but it's also to say it's not like yet a completely official part. Like, we still, if there's any bug, then I'll go and fix it. That's not a problem, and you can use it and be confident. But the plan is, and this is basically what I'm trying to say, the plan is for EF Core 10, which is coming out in September of this year, more or less, or October. Sorry, more in October. The plan is to fold it into the SQL Server provider, so you have it out of the box, and we don't need an external NuGet that is not an official Microsoft product. So just to give everybody the idea about how this works.
Yeah, that's cool.
And there was a question from the audience. I think I can put it on the stage, which says, could we use Azure SQL Vector Search in layer of AI Search /Quadrant in a .NET EF Core project?
Absolutely, yes. So I'll dive into that a little bit more. It really depends today on how many vectors do you have. If you have less than 100,000 vectors, definitely that's what you want to do. If you have millions and millions of vectors, right now, Azure SQL and SQL Server doesn't have support for vector index yet. We're working on it. But usually vector index, unfortunately, indexes are not the right word when it comes to vectors, because it's really doing approximate search, and usually index is precise, right? So we call vector index something that is not really an index. So that's why you need to be careful when you decide to use it or not, because basically when using a vector index, you will be choosing between having fast result versus right result, or more correct, precise result. And so the recommendation I see now coming very common in many places is that if you have less than 100,000, 50,000 vectors, you probably want to do what is called an exact search. So don't use a vector index. So you always have all the result you would expect. If you have more than that, since searching between vectors is very expensive, you probably want to exchange a little bit of precision for speed and less resource usage. So that's where the vector index come into place after you really have a lot of vectors.
Maybe I'll also add one more thing. Like, we're getting a bit deeper, right? But I think, Davide, what you're saying is basically if you're going to do a search over 1 million vectors, then of course a flat search becomes kind of untenable in terms of performance, right?
Yes.
However, and here I want to make sure that people understand, many times you're not actually taking your whole table, like your whole database or table, and doing like a similarity search over this, right? What you will many times be doing is you'll actually be applying a where, like a filter, just before you're actually doing the similarity search. For example, let's say you want to do a similarity search, but only on shoes, on your products which are shoes, or only on a specific tenant, right? So you have a where clause in your SQL there. that it gets evaluated before the order by. So those of you
That's
who know
right.
your SQL, obviously, where comes first, order by comes second. So if your where clause basically took this huge table of millions of rows and already uses just a plain traditional relational SQL index, like super boring stuff, and it uses that index to reduce the number of rows, and then the vector similarity search kicks in, then you're fine, because you're no
Yes.
longer doing the actual, vector similarity search over millions. So I'm kind of saying the question here is actually a little bit, you have to go into the details of exactly what you're trying to do.
Correct.
But I'll also say one of the nice things, one of the things that I love about this SQL Server support, the question here was about, can we use this instead of Quadrant, right? And Quadrant, for those of you who don't know, is just an example of a product. It's a vector database. It knows only to do, it's basically a database. It's a type of database that is only geared towards this job, right? Whereas SQL Server and Azure SQL obviously are general purpose relational databases that also have these vector search capabilities in them. One of the nice things about this approach with SQL Server is if you already have your SQL Server or Azure SQL thing, then you don't typically want to add another database which you now have to maintain, keep online, and also synchronize data-wise with your main data store, which is SQL Server, right? You ideally just want to shove all of your data, including the vectors, into a single database, and you don't want to. That's like the simple thing. So this is the really nice thing about what the SQL Server thing. Though I will say, like Davide was hinting at, there are certain capabilities because the Quadrant and those other kinds of products are very dedicated to this task. They only specialize on this. In some things, they will be slightly ahead of what SQL Server can do, like what Davide was saying in terms of the indexing and there's various things like types of embeddings. Like here we're looking at float, so 32-bit floats. The industry is actually seeing that there's sometimes a good reason to use smaller ones, like a half, which is a 16-bit. In some cases, you even use a binary embedding, like ones and zeros. So there's all kinds of things that you can do in this world, and obviously a general purpose database will be maybe slightly behind on this because it's not the only task that it does, right? So there's a decision here to be made when you're starting out what you want to do and what you want to prioritize. Anyway, that was my
no, that's actually a good point. So I just want to add a couple of things since you brought them up. So the first one is about how do we perform against a large number of vectors. As you said, basically you shouldn't take into account the total number of vectors you have, but the vector resulting from applying all the predicates, because then we do the vector search only on the residual predicates. So if you have, for example, I have an example where you have 10 million of vectors because they represent reviews all across the world, of places all across the world. If you search only for reviews in Seattle because you live in Seattle, then we first of all apply the filter to reduce as much as possible the vector search, and then we only do the search on the residual predicate. Usually is 50, 20, 30,000 vectors, probably even less, and then it's super fast. The other thing about using an external database is what we are noticing with many customers is that the moment you move data outside the database, you need to take really care about security. No, I wouldn't even mention integration, like what happens if I delete a vector on one side and not the data on the other. Let's pretend that this problem is not there. But security is a huge problem because vectors represents information. And actually there are attacks that can reverse engineer the vector and come back to the original
interesting.
meaning.
That's a very interesting point.
Yeah. So it's very, very delicate. So the moment is like taking the full text outside your database. Yes, you can. Yes, you have advantages. Just be aware that then you have to also manage security there. And if it's something very sensitive for you, you want to think twice. So as usual, you have all the options here. Moving data outside the main database means you have to deal with more stuff on your plate. If that's worth for you, do it. Otherwise, I think Azure SQL is a great place for vectors. Now I'm seeing some of the comments here about someone has tested the vectors with 100,000 vectors, and it wasn't a good idea because apparently it wasn't fast enough. That's definitely possible because vectors are very resource intensive, right? And if you have a small database or a small machine, like only 2-4 vCore, not much memory, a slow I/O, scanning for vector it will take seconds, right? So in that case, you may still want to evaluate for an index. Again, you're exchanging precision for speed, and if that works for you, it's great. But in general, just keep in mind that vectors are each vector, for example, the 1536 dimension is 6K. Each vector is 6K, right? If you have 100,000 and you have to scan through all the vector, it's a lot of computation that we need to do and a lot of I/O that we need to access, which means you need to have a pretty beefy machine to do that with the performance that you expect, right? So just keep that in mind, just to answer some of the question that I'm seeing.
One
Okay.
question that we
Yeah.
can maybe answer that's kind of unrelated, but it would be nice to have it as well. And it's, could we save image
Oh, that's
content in
interesting.
vector type?
Good question. Yeah.
So
I was just looking into this too.
Yeah, so it cannot, because vectors are just vectors, so you cannot store an image, but you can generate embedding out of an image. So for example, if you have an embedding model that supports multi-model embeddings, and for example, we have one in Azure, in Azure AI services, you can generate an embedding from a picture, and then store that embedding in your database, and then someone can type, find me all the pictures of Rome, and that picture that is as close as possible to the topic you are searching will be correctly found because we are using the embedding. So it's not about storing this. That will also work with sounds, right? So you can generate embeddings out of pretty much everything. Text, sounds, images. And then once you have a model that is able to generate embeddings on a multi-model source, you can freely search all across of these embeddings. So you can do the sound of a bird and ask what image is related to the sound of the bird I'm mimicking, for example. You can have this pretty nice, interesting interesting stuff. Yes, I have actually a demo of it, but I don't think I will show it today, but it's pretty impressive.
Okay, and kind of question that's repeated with every our guest. Are you using Azure Data Studio?
No. No, because Azure Data Studio has been deprecated. So I'm using the MS SQL extension for VS Code, which is basically trying to replace Data Studio, but in VS Code. So a developer, as myself, doesn't have to move between tools. So here I'm using this extension here, MS SQL.
That's official. Okay,
that's
cool.
The official
I didn't
one.
even know about it. Yeah.
Yeah, it's
cool.
The official one is the one where we are putting a lot of resources and investment, because we got from developer the clear message that switching tools create a little bit of a friction in the experience. So if they could have in one tool the code and the database, they would have been happier. And so we listen and we're doing that.
Nice.
Yep. Okay, cool. So let me now move quickly. So here I basically added all my blog posts. I get the embedding for the text, saved them in SQL in show the table here, in this table here, so the one that you saw before. And then behind the scene, here we go. So the embedding has been generated. And then I've been doing the search to basically find all the posts that are similar to the question I asked, which is, I want to use Azure SQL and EF Core and Vector in my app. So if that's the topic I'm interested in, what is the closest post I should read? Well, definitely it is one. In fact, it's the one that is closest. And Node versus Rust is definitely something I may not be interested in. And now there are also, for example, posts about chocolate eggs or focaccia and pizza, whatever. Of course, they don't even show up because they are very far away from my interest, right? So this is cool. This means that in a very few line of code, you can start to add semantic search to your application that makes the life for your customer and user so much easier, because now you don't have to find a specific keyword, right?
Yeah, I want to drive this point home, like the original thing. Like of course, you can just use SQL when you do a search on your website for an e-commerce, like a shop or whatever. Sure, you can do a search and you can just do a where clause and do a contains and use, for example, like, right? So you can search if something is inside. Of course, that's a very literal thing. And for example, if the guy looks for feet because they want shoes, but they write foot, then it won't find it because feet and foot are not the same. So that's already a stupid way to do search. search, right? Or not a very efficient way to do search
Yeah.
for actual human text. And then you've got the really cool feature called full text search in SQL Server, and also in other databases, which has been around. This is not new at all. This has been around for many years. Full text search is already a feature inside SQL Server, which is aware of human language. So it can do stuff like know that foot and feet are actually the same thing. It can normalize it back. It can do stuff like be aware, it is aware of plurals. It can do various things that it can already see through human language, let's say, in that sense. However, it's still, if the user searches for something like boot, and then what you have in your product catalog is shoe, then of course these are still completely different words, and it obviously does not work at all, right? So this is exactly where semantic search comes in a very, very cool way, because it's actually aware of meaning. For the very first time, what this whole vector magic allows you to do is to actually do search that is related to the meaning of what's happening there, right? Which is the really, really cool things. Just in case this wasn't clear, this allows you to do just, whatever, a product search on your shop that is really aware of how humans really use language, which I personally find magical every single time that I see this at work. Like, I think it's absolutely amazing. So yeah, back to you, Davide.
No, yeah, I was just trying to enable the logging, which I think I did. Well, before coming here, I made a small change. Let me just do a brutal log of everything, and then we see here we go. Now, probably I didn't save then before. That's what happened. Okay, so now that's the interesting part. Okay. So this is what's happening behind the scene. You see a lot of numbers on the screen. These are the embeddings that are generated on the client and sent to the database, right? Now, this is great, but also keep in mind that each embedding is 6K in this case, right? Actually more, because the representation is in JSON format. So that's why we also added a lot of features to generate embedding in the database itself, because again, it's up to you to decide where it makes sense to generate embeddings. The moment you generate embedding in the application, just remember that you have to move quite a lot of data back and forth. So up to you to decide where it makes more sense, but we wanted to make sure that you can also have the option to generate embeddings right in SQL. And this is exactly the query that is generated for finding the most similar blog post to the embedding that represents my query, generated by EF Core, which is very elegant and very easy to understand and use. So pretty cool. So EF Core basically got developers covered for everything that is related to using embedding and vectors in Azure SQL Server. By the way, the vector support will come with SQL Server 2025. So right now it's available in Azure SQL, Fabric SQL, and SQLMI as a public preview, as you were mentioning. GA will come very soon, so stay tuned. But that's where we are today. Now, the other thing I want to show is using also, and I can close, well, let's keep this open just in case. Show, this is definitely something I can close.
Maybe we have time for a question, or you want to...
Semantic kernel is probably the other library that you want to use if you... Oh, yeah, absolutely.
Oh, sorry, I think we got a delay here a little bit. Maybe
yeah, that's nice. So this is a very common question, like, okay, vector search is great, but sometimes I want to mix it and match it with full text search to get the best of both worlds. Now, this is super fun for me because it shows how, let's say, we can improve in our marketing. We had BM25 since 2000. We just simply never mention it, right? So BM25 is available in SQL Server full text since when I got memories of me using SQL Server. And yes, so we just never disclosed that we are using that algorithm behind the scenes. So now we updated the documentation. And
that's true. I've always heard about full text search, like everybody knows about full text search, but this word BM25 only really recently became very popular and everybody's talking about it. That's true.
That's right. So let me search in this AI-powered website that I built as an example for BM25. You will see that hybrid search will pop up. And then if you go to this website here that I'm posting in our internal chat so you can share it with everyone, you will have a full example. The code is in Python, but internally it's all SQL, right? Where I show how you can use free text table, which implements BM25, vector search, and then calculate manually RRF. We don't have a special function to call RRF, but RRF is nothing more than a division and an addition. I think you can write it on your own. and that's basically hybrid search. That's the code that you need to do hybrid search.
So this I wanna also call back, because there was a person before who asked about RRF. Like we mentioned RRF in the intro, and somebody was saying, "Hey, what about RRF and everything?" So we're basically showing this now. The idea is basically that vector search, the similarity thing, is not always sufficient, and to get even better quality, sometimes you want to mix it together. And there's this idea that you take multiple searches and you combine the results. And by the way, in theory, RRF, like this idea of combining multiple results, it's not just, so usually when we talk about hybrid search, it means vector search plus full text search, like BM25. But in theory, at least, there's nothing preventing you from doing something like, for example, 2 vector searches and combining the results, or 2 full text searches on completely different text and then combining that result with something else. Like you can, in theory, take in N searches and combine the results via RRF to basically, you get like 2 sets of rankings, right? One from each search, and then you combine them to get a single set of ranking. That's all that we're doing here, basically.
Absolutely.
Right?
Absolutely. And it's actually pretty simple. Again, it's nothing really complex to implement. So yeah, we support BM25 in full text. So just feel free to use it. Actually, it's also available in Azure SQL. It comes for free. You don't have to pay anything additional to use that, and it's just working. So any other question before we move on?
Don't think so.
Okay.
There's a request to share the URLs, by the way.
Oh, yeah. I can do better, actually. I can do better. And you can just, so let me share something I built over time. If you go to awesome.azuresql.dev, but of course spelled correctly, awesome.azuresql.dev. Oh, actually, this is something I'm working on, sorry. AzureSQL.dev. That's it. So you go to AzureSQL.dev.
Nice.
Pretty easy, yes. And then you go to this Azure SQL DB samples AI search, and then you can use AI here. Everything is happening in SQL Server here, right? We decided just to showcase that you can do everything in T-SQL. You don't have to, but when you really look at the code, everything is done in T-SQL here. You can choose, for example, let's see, Semantic Kernel samples, and you just type the search that you want. It will run hybrid search behind the scene, and then you will get the answer using a full RAG approach. So this also, send the result to an AI model and explains why the results are relevant. For example, here it gives you an explanation on why that sample returned is relevant for your request, right? So this is nice. Going to the next level, which I will be discussing in a second. It's taking a semantic search, actually hybrid search, and then passing the result to an AI model to even refine it more and to make sure that all the results returned are in scope for the question. And the reason is very simple. If you say, told me about spring, it's about spring water or about the spring, the season. You can only understand if you have a bigger context, right? So semantic similarity will stop there because it doesn't understand the bigger context. If you want to make sure that something talking about the spring water is not return a result when you ask about spring, the season, you need to move to a more refined AI model like GPT-4o, right? That's exactly what this example is doing. So kind of a evolution of semantic search. Having said that,
I would like to remember to everybody that we have a page on learnmicrosoft.com where every show is posted with the links and everything. So if you don't want to type the links and everything, in like 24 hours after each show, we have links and everything we mentioned in the show available there. And you can just click on it and explore the code or whatever was presented.
Now, let me just quickly switch to semantic kernel, because of course we work together also to make sure that the vector support is available in the latest and greatest semantic kernel features, and specifically also in the new evolution that goes toward the vector store implementation in the Microsoft extension.
Is it worth saying 2 words about what semantic kernel actually is, and then maybe Microsoft Extensions
Yes.
vector data? Do you want to
Please.
go, or should
No,
I
no,
go?
you are the master of that. So yeah,
Yeah, I'm not.
you go
So
for it.
semantic kernel is a project, basically it's basically a stack for building AI applications. This is not EF. It's not related to EF in any way. That's a completely different, let's say, team as well, working specifically on doing AI technologies, both for Python and for .NET. It's kind of like a stack. You can think, in Python you also have LangChain. It's a different kind of stack, but it's something like this without going too much. So if you basically have a kernel there, and you do all of the integration with the LLM and all the other different components. Originally, since vector databases and vector search are such a key component of basically every AI application nowadays, there was also support in semantic kernel, which is again a completely separate project. There was support for accessing vector databases, and it started out as something that they built. But then we're actually, over time, we kind of figured out that vector search, like the thing that you're seeing here, is a general concern that .NET developers need to be able to do. It's kind of like a foundational thing, just like we have a .NET API for accessing SQL databases, right? We have ADO.NET or system.data, which anybody can use to access any database. It can be SQL Server or Postgres or SQLite. And EF data can exist partially because it can be built on top of ADO.NET. So you need this sort of foundational layer to access relational databases. And we basically came to the conclusion that we need the exact same thing for vector database. We need an abstraction for doing things with vector databases, no matter what they are, SQL Server or Quadrant, Postgres, SQLite, the Milvus, doesn't really matter. So then we work together. I have spent a lot of time in the recent months, maybe even my main thing has been to work together with the semantic kernel team. And we basically brought this into something new that if you wait for another week and you listen at Build, you will hear an announcement. We're basically delivering something called Microsoft.Extensions.VectorData. It's like a new API, a new part of .NET now, that is this abstraction for vector databases. It grew out of semantic kernel, so they originated it, but then together we sort of matured it and made it for what it is today. You can see Davide is now highlighting it. So technically what you're about to see, what Davide is about to show you, is no longer part of semantic kernel. I'm kind of stressing this because what you can see now, it doesn't mean you have to now use semantic kernel, which is its own stack and set of things, which I absolutely recommend taking a look at, but it's not for everybody. And if you don't want to use semantic kernel, that's completely fine. You can build your application without it. But Microsoft Extensions Vector Data is not part of that anymore, although it used to be.
Yeah.
And now I'm going to hand it over.
But I must say I love semantic kernel. It's one of my favorite.
Yeah.
So you should use it, and I'll show you why in a second.
It's a bit like, you know what, I'll say it like this. I'm absolutely not saying not to use semantic kernel. For example, I work on EF as well, right? That's one of my main things. But it's important that you don't have to use EF in order to access databases either, right? No. Like in the .NET space. So you can also drop down and just have this foundational thing and just send SQL to your database and not do this thing. But indeed, if you want to build an actual application and you want to orchestrate basically all of the things together, this is where semantic kernel becomes amazing. Absolutely. And you don't want to do this from scratch.
Yeah, so, I just wanted to say it because you work in the team or somehow very, very close to that. So of course one may think, oh, well, he's skewed a little bit biased. I'm not. And honestly, when I started using semantic kernel, moving from other libraries, it's like day and night, right? Semantic kernel is so clean and so very well architected that it's just a pleasure to use. And actually, you can build, I'll show in a couple of minutes, something amazing in a very few lines of code. So just to introduce semantic kernel and the new vector support, basically, what I'm doing here is just declaring a class where I also say for each property, each element here, how it plays in a bigger picture of storing data and vector together. So here is just regular data, but here I have my vector, right? And then basically I can use the new function to say, okay, I just create my, a list of my new class to store all the glossaries information I have. I create the semantic kernel and easily connect to a model that can generate embedding for me. Then I start the SQL Server vector store. So the vector store, this will create the table behind the scene that is able to store the data as I describe it here, thanks to the attributes. And then basically I just use it regularly. I get the collection. In this case, a table with this name will be created for me, since I'm using create collection, not exist. Then I generate the embeddings, again, on the application this time. Then I update my data. I insert, in this case, I'm just getting back the data I inserted as a test, but then I do vector search, and exactly as it was happening before, behind the scene, vector search will be used, and the most similar result will be returned. So it's very, oops.
Oh, I have a lot to say, but I'm going to shut up.
No,
I have to hold myself.
Yeah, it's a lot of stuff that is coming, and it's super interesting. This New York.
Yeah. So much.
Yeah. So definitely, I'm hoping you will be doing a specific session on that, because
oh yes,
it's very nice to use.
Obviously.
So just a simple example here, but behind the scene, this is the table that will be created for me and populated with data. This is the embedding that's been generated for me. And as soon as this, let me go to the terminal. Nice. Now everything has been added. Then I run vector search. And of course, if I want to learn more about connector, what is the most similar topic related to this topic, given the three glossary item I inserted, of course, this connector term, as you can see, is the one that has the closest distance. So it's very easy, very clean, very well done, I would say, very polished. You just create your class, decorate it, and use it. And the beauty is that if I want to, I actually built this example by using an in-memory vector store example, and then I just switched it to SQL Server, and it just worked. So it's very nice. Yeah. Completely abstracted from a database, if that's what you're looking for. Now, something
was a question about SQLite Vec. So what I can tell is that, for example, the SQLite with the SQLite Vec extension has a great support in the current Microsoft.Extensions.VectorData and everything. It's like fitting together nicely. So exactly as you said, if you would like to try it like locally, for example, instead of going to the real database because you are debugging, testing, then in memory or SQLite is a great option for this.
We're actually right now working on improving .NET integration with SQLite Vec. There's some challenges there because SQLite is a native database and the extension is native. That always creates a bit of difficulty, but we're literally right now, just now, working through all of this, and it's getting better. Is it okay if we say just a couple of words about the semantic kernel thing?
Absolutely,
So actually, I want to ask you, I want to hear your answer to this. It's actually always interesting to me to get this question as well. So you've shown two models of actually accessing vector search in SQL Server, right? Or Azure SQL. One was to use ZF via link queries and that stuff that you showed before. And now you're showing this other API called Microsoft.Extensions.VectorData related to semantic kernel. So why would I use one or the other? Why would I choose this or not that? Like, which is there a recommended one? Let's say I'm kind of, somebody who wants to go into this, what should they do?
Oh, if you're asking me, I would say if I'm using already EF Core, then I will definitely use the extension because it's the natural way for me. If I'm starting from scratch and I don't plan to use EF Core, then I'm free to use semantic kernel and have basically the same nice experience, but without having to be forced to use a library that I may not need just for that purpose. So that gives me the total freedom. Right.
So that's indeed, that's very close to my answer as well. Like I get this question a lot as well. Like it's complicated to explain this a little bit because it's really two completely alternative methods of doing the same thing, right? Basically, I'll add just a few more very small comments to what you said. So first of all, obviously EF Core is all about very, very, very comprehensive query support and all of the capabilities of databases. So if what you want to do is express very serious queries in SQL, which also happen to do vector search, that's more of an EF Core task because the semantic kernel or the Microsoft Extensions VectorData that you see there is going to be very limited in terms of the type of SQL that it supports. You're not going to be able to do big joins and group bys and all that stuff does not work. It's quite a simplistic model of what a data store looks like that does this thing, right? So if the point here is to, like basically what Davide, what you just said, if the point here is to take your existing application that uses serious Azure SQL with all of the good stuff in the SQL, and you want to also start to integrate to infuse it with vector search, definitely you're continuing to use EF Core, and you'll be using this plugin that you just showed to just add this capability. However, if on the other hand, what you are doing is, let's say, more of a search first kind of application, like a vector search AI first sort of application, then the other approach of Microsoft Extensions Vector Data might be the more correct one. Plus, this is less interesting for SQL Server necessarily, but Microsoft Extensions Vector Data captures a much wider type of databases. So you can use Microsoft Extensions Vector Data for Quadrant, for all kinds of vector databases, and also switch between them. Although of course, you cannot use EF for Quadrant. It doesn't make any sense. Those two things don't fit together because these dedicated vector databases are just not a good fit for something like EF for many, many reasons. So it's two very different approaches. It's really not an easy question to answer, right? And it depends what kind of application you're doing. And one of the nice things, what I'm excited about personally as well, is that with this abstraction, as with any abstraction with the Microsoft Extensions Vector Data, you can now build some sort of generic component on top that will now take any vector store, SQL Server or something else, and do something really, really cool with it, like a RAG, like a retrieval augmented generation framework, or something like this. You can start building like a whole stack of AI technologies on top of this stuff, like Semantic Kernel. That's exactly the kind of thing that Semantic Kernel does. And that doesn't work that well on the EF side of it, right? So yeah, that's kind of like the way I view this whole thing.
Talking about Semantic Kernel, let me show something. If anyone is interested in what I'm going to show, and I bet you will be, go to the ai.awesomeazuresql.dev link I shared before, and then just type insurance demo. And that's exactly what I'm going to show. But so you know how to get to this demo, because I'm pretty sure you will want to download it and try it. So exactly, this is the one that I'm saying. So I'm heavily going to use Semantic Kernel and its capability of orchestrating many requests to the database. So the database I have here, it's I would say a common one. I have, for example, I'm in the right one. Yes. So I am simulating a simple insurance. So you have the customers, you have the claims, you have the policies, and you have all the communication history that has been done between a customer and the insurance, of course, encoded with vectors. So we can do semantic search on any mail, any phone call, anything that has happened. So what I want to do right now, and I will be using Semantic Kernel to do that, and I will be starting in debug mode so you see what happens behind the scene, is build a chat bot that can help me, imagine me being the new hired insurance agent that needs to access data about a customer. And systems are complex, I'm new, and I need to meet someone today. And what can I do? Well, if I have an AI agent that is able to help me, I can just start to talk with it, right? So here I'm using Semantic Kernel, generating some dynamic plugin that helps Semantic Kernel to understand how to query the database. And then as soon as this starts, you will see that I can start to chat with my database. And the Semantic Kernel will figure out what is the right table to query, generate the query for me, even do semantic search if needed. And I can be able to just chat with an agent. As usual, when I'm presenting, it takes much more than when I'm not presenting, but here we are. So, hi, I'm meeting with, let's say, John Doe today. What can you tell me about him? So now Semantic Kernel is doing the orchestration, is taking this question and trying to understand what it can do. And of course, it figures out there is a table called customer. So it's generating for me the query and executing it against database. And well, here it goes. And there are a few individuals here. So I need to say, well, I'm meeting with John from Redmond. So he now has, now the AI model has all the information, and the Semantic Kernel start to orchestrate using many different functional tools to query the policies, to query the claims, to query any additional history that we may have. And here we go. I have the full kind of thank you, the full summary of the status of my customer. Now, I know John Doe is a little bit upset. So let's tell him John Doe is upset about raising costs. What is he a good customer? Good customer. For example, I just want to understand if it's something we should keep, or maybe it's just making us lose money. So yes, it's.
I just note that you even did a typo there. Is he a goof customer?
Oh, that's right.
And that's completely fine.
Yes.
The AI is AI. It understood that he can be considered a good customer, obviously.
Exactly. So that's pretty
Very cool.
nice, right? And here you can do all sorts of analysis now. Okay, show me the price, the premium increase in the last years. So let's see why John Doe is complaining. And he was paying $2,000. Now he's paying $3,000. So yes, I agree with this guy. So you see, you are talking with your data, and thanks to Semantic Kernel, the code, you will see it's super simple, because you just created the tools that allow Semantic Kernel to understand that this tool, which is a function, can query the data in the customer table. This other will query the claims table. And then all the orchestration that is actually the complex part to do is mainly taken care by Semantic Kernel. So this allows you to create amazing application that gives the feeling of really talking with a person, like a Star Trek vibe, where I can just talk with the computer and just work. I can now, the beauty with Semantic Kernel and the fact that you can store kind of vectors and memories in the kernel is that you can inject memories about something that you want the AI model to remember. So here, for example, I can say I injected some memory about new discounts, right? That our company is doing for good customers. So I can say, is there anything I can do to help reduce the premiums? And again, with a mistake. And yes, there is this safety score thing. So it's beautiful, because you have on one side your ERP, right, where I created my table to simulate that. Then I'm using the vector, the new vector search capabilities and the vector store, just as a kind of a collection of memories that I want my AI model or my AI bot to have. And the Semantic Kernel is helping me to put everything together. It's very, very, very nice, very elegant, and it's really a bunch of line of code. And they are all available here in this chat class, where you see that I am initializing the Semantic Kernel. And then where it's here, well, here I'm using the older version of the memory store. I should update it. I will do in the next days. And then just basically doing the cycle to handle the back and forth between the human and the agent. So very, very nice. And that's it. These are my functions, and super, super cool, I would say. So this is just to give like a, from 0 to 100, an overview of why we added vectors to SQL, why we wanted to have the libraries that and use and love enabled with vectors, and what can actually all these library and features allow you to build or enable you to build. That's what I just showed. And I think this is great. If you show something like that to your boss or your customer, they will say, yes, I want it, like tomorrow. That's the experience I had with everyone that saw this demo. So yeah. I'm happy to share the code with you. Just feel free to use it.
Even I want this. I don't know anything about insurance. I still want this.
Absolutely. So go here and this is the link. Search for insurance demo and you will find it. And then you just have the link and then you can go from there.
Very, very awesome. Very, very awesome. Yeah, there's tons of stuff coming out that's very exciting right now. Do you know exactly when the SQL Server 2025 comes out with this support? Is this something you can say, or
I wish,
or
no.
very close?
Let's say that so keep an eye on Build next week. There will be announcement, and then of course we want to make sure that SQL Server is available as soon as possible to everyone, and that moves to GA as soon as we can, but I don't have any data I can share at the moment. But definitely will be within this year, for sure. Otherwise, it will be
very
good
cool
for me. Yeah.
And then on the other side of it, we're going to have, so again, EF Core already supports this stuff, but it's going to come into the box, let's say, and it's also going to be, so for those of you interested, currently SQL, like let's say the older way to support vector search in SQL Server was a less efficient way to store and to transfer the data of the vectors under the hood. So there's a shift to now make this more efficient, and that's also planned for EF10. So there's improvements on the EF10 side that are planned to bring this into the box, make it more efficient, support everything, and so on and so forth. And then there's also this whole story of, what we've been referring to here as semantic kernel, and which is a bit more, let's call this Microsoft.Extensions.VectorData, which is basically an abstraction for accessing vector databases with, of course, obviously a provider for SQL Server, which we developed. So then you have also that way of accessing all this wonderful technology and functionality, whether you're using semantic kernel or not. There's a ton of exciting stuff. I'm personally like the rhythm of things happening at the moment in this space is like, this is all I'm doing at the moment, and it's really mind-boggling. Sometimes you get a little bit dizzy with how much stuff, but then you see these kinds of demos and you kind of, it's incredibly cool. And 5 years ago, nobody thought that you could do something like this.
That's right. Yeah.
Right. It's amazing.
So just something, it seems some people cannot, unfortunately, the dev, I noticed, I'm learning that the .dev kind of domain doesn't work everywhere, apparently. So if you're interested in this demo, the one that I just showed, the semantic kernel one, I'm pasting, VPN usually fix it if you are in some corporate environment. But yeah, I just also pasted
very strange.
I just pasted also anyway the link to the semantic kernel sample with the bot. So maybe you can also share that, and then we're good.
I'm doing it.
Thanks.
Very cool.
Cool times. Really exciting to see. The next generation of applications will be pretty cool, I would say.
Absolutely.
Yeah.
Awesome.
Well, I think that's all for today, and it's enough. Yeah. I think it's.
Oh yeah. This was
cool, right?
Huge amount of fun. I think a lot of information. Like, I'm personally super thankful. It's super cool to see all this like in such a nice package and seeing all the different ways to access it and everything. It's like perfect. Yes. Thank you very much for coming.
Well, thank you for having me. See you next time.
Thank you, Davide.
Absolutely.
Thanks, everybody. See you next month.